Hi guys, this is video 2 for you to review about the final exam. We left off looking at the last bullet points, which were talking about basically stoichiometry and how much product can I make with a certain number of reactants, and how much reactants do I need to make a certain amount of product. That's one thing. Next was, what if I have only a certain amount of both reactants? How much product can I make, and which one's limiting me? Which one's my limiting reagent, right? Another thing was, what is the percent I actually got? So theoretically, I calculated how much I was able to make, or I should have been able to make, but I only got this much in the lab. And how much was that? What percentage did I actually get back? That's percent yield. And the last thing was, briefly, acids and bases. Cool. So let's take into consideration our equation from video 1, which was magnesium plus HCl gives me MgCl2 plus H2. Fantastic. Now let's say I want to find out if I only have 10 grams of magnesium. So I have 10 grams of magnesium. That's a reactant. How much MgCl2 can I make? How much MgCl2 can be made if I have an excess of HCl? So let's say I have a huge bottle of hydrochloric acid in the lab, but I only have 10 grams of magnesium. And I want to find out how much magnesium chloride can be made. All right. To do this, I have a 4-step easy method that I had you guys do in class several times. But before I even begin that 4-step method, I want to calculate the molar masses of my products and my reactants. So looking at a periodic table, I'll see that Mg is 24.3 grams per mole. HCl, H is 1, and Cl, chlorine, is 35.45. So that'll give me 36.5 grams per mole. Here, Cl2 is going to be 71 plus Mg, which is that 24.3. Those will come together to make 95.3. And H2 is simply 2 grams per mole. So now we've done quite a bit of work already. The rest is just plugging and chugging. So to solve stoichiometry problems, step 1 is to, that's kind of a big one. Step 1 is to balance and find my ratio. Step 2 is to convert what you have, convert given to moles. Step 3 is to use my ratio from my balanced equation. And step 4 is finally to convert to grams. Alright, so let's do each one. First I'm going to balance. I've got 1 magnesium here. My coefficient is 1. And I also have 1 here. Fantastic. Hydrogen, I've got 1 here and 2 over here in my products. So I have to multiply this whole thing by 2. 1 Mg, 1 Mg, 2 H's, 2 H's, 2 Cl's, 2 times 1 Cl is 2 Cl, and 2 Cl. Fantastic. So it looks like it's balanced. Alright, convert what I'm given to moles. In my question, I have 10 grams of Mg, and I want to find out how much MgCl2 I can make. Alright, my ratio is going to be 1 to 2 to 1 to 1. And we'll look at that in a moment of which ones I use. And finally convert to grams so that I can end up with an answer of how many grams of MgCl2 can I make. That's what my answer should be in. So let's do it. You can pause the video and maybe even skip ahead if you want. But it's completely up to you. Let's use the yellow, yeah. Okay. So, step 2, I'm going to convert what I'm given into moles. I was given 10 grams of magnesium. In 1 mole of magnesium, I have 24.3 grams. Cool. Step 3, I like to draw a box to remind me that this is where my step 3 is. It's where my ratio is according to my balanced equation. Right, so I want to get rid of magnesium at this point, and it looks like my ratio is 1. So 1 mole of magnesium. And if I look at my products, it looks like for MgCl2 it's also 1. So 1 mole of MgCl2. And finally, over here, we're going to get rid of moles and get grams of MgCl2. And in 1 mole of MgCl2, magnesium chloride, I have 95.3 grams. So 95.3. Great, to solve this, I'll do 10 times 1 times 1 times 95.3, right? Which is going to be 953 grams, divided by 24.3 times 1, so 24.3. This should give you, I'm going to solve it on my calculator now, so 953 divided by 24.3 equals, I get 39.21 grams of magnesium chloride. So that would answer, how do I solve a problem where I have a certain amount of reactants? How much product can I make? Of course, you could do the same thing for H2. All right. So now let's say I want a certain amount of product. I'm sure we've all faced this before where we said, hey, you know what? I want 24 grams of magnesium chloride. I have a huge box of magnesium sitting in the lab. How much hydrochloric acid do I need to get? All right, so I have an excess of magnesium. So the question is, how much HCl is needed to make 24 grams MgCl2. All right. So let's answer it. Our equation is already balanced here. And the two things I'm looking for, I have an excess of magnesium, so I can ignore it. How many grams of HCl is needed to make 24 grams of MgCl2? So I start with 24 grams of MgCl2. My step 1 was to balance. Step 2 is to convert what I'm given to moles. So let's convert this to moles. In 1 mole MgCl2, I have 95.3 grams MgCl2. I didn't do that right. Didn't feel right. In 1 mole, I'm converting to moles, so I have to get rid of grams, so grams goes on the bottom. 95.3 grams. So in 1 mole of MgCl2, I've got 95.3 grams. Fantastic. Now here I'm going to multiply by the ratio. So grams MgCl2 can cancel with grams MgCl2. I have to get rid of moles MgCl2 now. So that's going to go on bottom. And it looks like in my ratio I have 1 mole, because my coefficient here is 1. So 1 mole MgCl2. And on top, I'm looking for how many grams of HCl do I need. So I'm going to look at HCl. And it looks like the coefficient for that is 2. So we're going to put 2 mole HCl. So now moles of MgCl2 can cancel with mole MgCl2. I'm left with moles of HCl. And I want to convert that in my final step to grams. So in 1 mole of HCl, I have 36.5 grams. So now mole HCl can cancel with mole HCl. My final unit will be grams of HCl. So when I go to the store, I can say, hey, I need this many grams of hydrochloric acid. Do you have that in stock, sir or ma'am? It's a problem we all face. So yeah, how do I go about this now? You're going to take 24 times 1. Be careful with that one. Times 2 times 36.5. You can pause the video now to solve it, or you can listen to my voice. Whatever you choose. So 24 times 1 times 2 times 36.5. That gives me 1,752. Above 95.3 times 1 times 1, so that's 95.3. So how many grams of HCl do I need? Looks like it's going to be honk honk 1752 divided by 95.3 is 18.38. So if you guys are looking to make 24 grams of magnesium chloride and you have an unlimited supply or a lot of magnesium, enough than you need, you could always go to the store and say, hey, I need 18.38 grams of hydrochloric acid, sir or ma'am. Cool. Fantastic. But now that's if I have an excess of one of the two. But now looking at limiting reagents, what happens if I only had, say, 10 grams of magnesium and 14 grams of HCl? For example, how do I solve how much product can I make? All right, just like my shoes and strings, I've got shoes and strings. I've got 10 shoes. I've got 6 strings. I can only make a total of 6 laced shoes because the laces are my limiting reagent. They're limiting how much I can actually make. See what I'm saying? So that's why knowing what I can do with what I have is important. But it's kind of difficult when I'm looking at grams and moles. So that's why we have to find out which one of the two reactants makes the less or the least amount of product, and that would tell me what's limiting me. All right, so let's try this. There's going to be a lot of writing here, so make sure you have some space in your notes. I'm going to do one reactant at a time and solve for both products. So if I have 10 grams of magnesium, first on top I'm going to solve how much magnesium chloride I can make, and at the same time on the bottom I'm going to solve for how much hydrogen H2 I can make. So 10 grams Mg. Cool. So all you have to do is set up your problems the same way we've been doing. I've got 10 grams of Mg. Convert that to moles. And to get to moles, I have to get rid of grams, so that's going to be 24.3 grams mg. And we're going to do the same thing on the bottom. All right. Now I'm going to get to my ratio part. So on the top one, I'm solving for magnesium chloride. To get to magnesium chloride, I have to get rid of magnesium, so magnesium is going to go on the bottom. If I look at my ratio, it looks like my coefficient for magnesium is 1, so I'll put 1 mole magnesium down here. And on top, we're going to moles of magnesium chloride, and it looks like my coefficient's 1, so 1 mole magnesium chloride. On the bottom here, I'm solving for H2. And again, it looks like my coefficient's 1 to 1. So 1 mole H2 and 1 mole of magnesium. So here, so far, grams of magnesium can cancel with grams of magnesium. Moles of magnesium can cancel with moles of magnesium. And same thing up here. Grams magnesium cancels with grams. Moles cancels with moles. Now, I'm left with moles of magnesium chloride on top. I want to convert that to grams. So in 1 mole of magnesium chloride, I have how many grams? 95.3. So now moles of magnesium chloride cancel out with moles of magnesium chloride. You can solve this now or continue to set up the bottom one as you like. It might be better to solve it completely. In that case, you don't mess up your numbers, but to each his own. To get rid of moles down here, in 1 mole of H2, I have 2 grams. So moles H2 cancels with moles H2. And you see how fast I did that? And if I wasn't talking, just writing everything out, it would go by a lot faster. But yeah, no problem. So let's do the top one. So the question is, how much magnesium chloride can I make with 10 grams of magnesium? You're going to do 10 times 1 times 1 times 95.3 divided by 24.3 times 1 times 1. And for that, I get 953 divided by 24.3, which equals 39.2 grams of MgCl2. I'm kind of running out of space, but we'll rewrite our answers in a moment. All right, for this one, I'm going to have 10 times 1 times 1 times 2, that's 20, divided by 24.3. Which equals, it's going to be kind of small here, but 0.823 grams of H2. So now that I've found out, I'm halfway done, by the way, with finding out my limiting reagent. But in this, I've now found out that with 10 grams of magnesium, the most I could possibly make with that amount of magnesium is 39.2 grams of MgCl2 and 0.823 grams of H2. So I'm done looking at magnesium. And we'll rewrite those on the side. So for magnesium, for 10 grams of magnesium, I was able to make 39.2 grams. That looks terrible. I'm so sorry. I was able to make 39.2 grams MgCl text Cl2 Let's try again. If I make it thinner. Let's try that. 39.2 grams MgCl2. Cool. And I was able to make 0.823 grams H2. It's important to keep track of these numbers, all right, to find out my limiting reagent. So now let's look at how much of these products I can make with my hydrochloric acid, my 14 grams. So we have 14 grams HCl, and I'm going to do another one on the bottom for both products. 14 grams of HCl. Convert them both to moles. Times my ratio. In the top one, I'm looking at MgCl2. I have to get rid of moles of hydrochloric acid, so that's going to go down. And it looks in my coefficient ratio, I had 2 here for HCl. So here's 2 moles HCl, and on top is 1 mole MgCl2. For the bottom one, I'm looking for H2, which has a coefficient of 1. And again, HCl has a coefficient of 2. I want to write HCl on the bottom to cancel it out with this. So we have 2 mole HCl. And on the top, I've got 1 mole H2. And finally, convert that to grams. So if I've got grams HCl, that cancels with grams HCl. Mole HCl cancels with moles HCl. Mole MgCl2 is going to cancel with 1 mole MgCl2. And on top, my final answer should be grams of MgCl2. And there are 95.3 grams in 1 mole of MgCl2. So moles MgCl2 cancels with moles MgCl2. We'll get an answer there in a minute. To finish setting up this one, in 1 mole, I ran out of ink down here for a moment. In 1 mole of H2, I have 2 grams. So moles can cancel, moles HCl can cancel, grams HCl cancel. Let's do this. 14 times 1 times 1 times 95.3 on the calculator says 1,334. That's going to be divided by 36.5 times 2, which I believe is 73. And that gives me 18.28 grams of MgCl2. So right away, I can already see that 10 grams of magnesium gave me 39.2 grams of MgCl2, whereas 14 grams of HCl only was able to make 18.28 grams. So clearly this is less. This is making less. Hydrochloric acid is my limiting reagent. It's that easy. For the bottom one, though, it's 14 times 1 times 1 times 2. That is 28. Divided by 36.5 times 2 times 1. That, again, is 73. On the calculator, that is 0.384. So look at that. If I were to compare the two, 10 grams of Mg can make a grand total of 0.823 grams of H2, and 14 grams of HCl can only make 0.384 grams of H2. This is less. So what's my limiting reagent? What's going to be limiting me? What's my strings in this reaction? It is the HCl. So I'm gonna rewrite these over here. I'm gonna erase all this stuff. Give me some room to write. And believe it or not, if you've gotten to this point on your own, fantastic. If not, that's cool. Maybe rewatch it or look at the examples I gave you that I worked out the problems for. Watch the other video that I made on this, as you like. So here's from HCl. From HCl, I was able to make that much MgCl2 and this much H2. Fantastic. Alright, so now let's just say in my shoes and strings example, my limiting reagent of strings was 6. I only had 6 strings, so I can only make 6 lace shoes. Just like this is my limiting reagent, that means that the most amount of product I can make is this much. In this particular reaction with this amount of reactants, I can only make 18.28 grams of magnesium chloride, and I can only make 0.384 grams of H2. Fantastic. So that means that after this reaction is done, all of my limiting reagent will be used up, but not all of my non-limiting will be used up. So this is non-limiting and this is limiting. Cool? So I'm going to have some magnesium left over. The question will come as to how much magnesium will I have left over? And to do this, this will be step 5 that I taught in class, which was you take what you start with minus what you start with times, and you could pick one of the products, the amount that you had that was limiting versus are divided by the non-limiting. So let's try this out. How much of the non-limiting will I have excess of? How much more will I have in the end after this is done? I started with 10 grams. So we do 10 grams of magnesium minus 10, that's what I started with, times, for this you could pick either product, magnesium chloride or hydrogen, but you have to stick with the same for both limiting and non-limiting. So for all intents and purposes, we'll pick the top one. So my limiting was 18.28 divided by my non-limiting amount for magnesium chloride was 39.2. If you do that in a calculator, you should get, let's see, 10 minus 10 times 18.28 divided by 39.2. On my calculator, I get 5.34 roughly grams of magnesium. That's my excess. Fantastic. So that's how much magnesium I'll have left over after the reaction is done. Cool. Now there's a question of let's say we went to the lab and we actually took 10 grams of magnesium and we actually took 14 grams of HCl and carried this reaction out. Based on our calculations, I should have only been able to make the same amount of my limiting reagent, which in this case was 18.23 grams of magnesium chloride and 0.384 grams of H2. So let's say we actually did this in lab and we were able to get 16 grams of MgCl2. We did the lab and we were able to get 16 grams of product. But when we were doing our calculations, we said, hey, we should have been able to get 18.28 grams. So in this case, you'll find out what was my percent yield, what was the percentage of what I was able to actually make, okay? So my actual yield, I'm going to write this out here. My actual yield is 16. My theoretical yield is whatever my limiting reagent gave me, which was 18.28. To calculate percent yield, we do actual divided by theoretical times 100. So my actual is going to be 16 divided by 18.28 times 100, and that will give you a percent. And in this particular instance, we'll have 16 divided by 18.28 times 100. That should be 87.5%. 87.5% is my percent yield. And that's it. If you know this, you know video 1, you guys will have a very strong, firm grasp on what's going on in chemistry. Also, how to be successful, I hope, on the exam. So let's finish up with a brief look at acids and bases. And we'll even continue with this equation. There's one acid in this equation. We're not going to shake it, but we're going to look at it. And let's look at it in green. Okay, we have HCl, hydrochloric acid. What is an acid? Acid makes hydronium ions in a solution. That is what an acid is. That's a definition of an acid. It's a substance that when I put it in, when I make a solution with it, that means solute and solvent. When I make a solution, it makes hydronium ions. What the heck is a hydronium ion? Let's look at that. First, we need to think of what happens if I were to put HCl into water. We learned that it ionizes. It becomes H plus and Cl minus. If I put HCl into water, that's H2O. So here's O, H, and H, right? We learned that once upon a time. Those were the good times when chemistry was Mickey Mouse. Right? If you remember that electrons have a negative charge, and here I have this hydrogen with a positive charge, these will form a type of a bond. It's not a hydrogen bond. It has a different name, but it will form a bond nonetheless between that positive and that the negative charges of these electrons here. So this whole thing is a hydronium ion. So what is the formula for that? It looks like I have 3 H's, so H3 and 1 O. And then I have that charge here, the plus. So this is a hydronium ion, H3O plus. Cool? If I look at HCl, I was only able to make 1 H plus. Let's look at that a little bit more. What exactly is H plus? If I look at just regular H, regular hydrogen, it has 1 proton, 1 electron, and neutrons is 0. If I look at H plus, that plus means that I lost an electron. So it means it's 1 proton, 0 electrons, and 0 neutrons. So what exactly is H plus? It is just a proton. That's all it is. So what we do is when we look at acids, we'll say, hey, how many of these protons can it give me when it ionizes? Right, so if I look at HCl, HCl will give me 1 hydrogen. So we say that it is monoprotic. This is referring to proton, and mono in Spanish is hand, but in this case it means 1. So this HCl is a monoprotic acid. It's going to give me 1 H plus. Cool? So how many hydronium ions can this make? 1. Let's give ourselves a little bit of space here. And that, believe it or not, is the most difficult part of what you need to know for acids. if you even think of that as difficult. If I were to have H2SO4, that's a popular one. I have 2 hydrogen here, so this will make a total of H plus, another H plus, and SO4 minus 2, right? I made 2 H pluses, so this is diprotic. We talked about this in the beginning of the year. And in the comments below, try to come up with a triprotic acid if you can. So there you go. Characteristics of acids that you should know are that they're used for cleaning. They make hydronium ions. They taste sour. They have a sour taste to them. So even if you have sour candy, look at the ingredients and you'll see something acid. Okay? Don't drink acids that are cleaning products. But a popular one that you might know is vinegar. Vinegar is an acid that is used for cleaning, if you've ever had to clean something. Next is bases. There's no bases here, so and I think we're good to go on this. I don't want you guys to have nightmares about magnesium and hydrochloric acid coming together. So bases, what is a base? Let's drop that base. Substance that makes hydroxide ions. So for example, you have NaOH, LiOH, CaOH2, calcium hydroxide, sodium hydroxide, lithium hydroxide. When they ionize in a solution, they're going to make hydroxide ions. Right? So if NaOH were to ionize, it would become Na plus and OH minus. Those are bases. Congratulations. These taste bitter. They're used for cleaning, like soap. If you want to know what bitter tastes like, put some soap in your mouth. Make sure you don't swallow it. Just a little drop. Make sure it's like hand soap so it doesn't kill you. You got to be safe. And I don't typically want you to taste things, especially different chemicals. But I think hand soap like Dial or the kind that's used at school or a bar of soap, just make sure you rinse your mouth out well. But that'll give you an idea of what bitter tastes like. And you can definitely think, hey, it doesn't taste sour. That's for sure. So in this class, that's as far as we're going to go into acids and bases. But I'm pretty confident, and I hope you guys go into detail with it in biology. There's a lot to do with acids and bases in your body, and also digestion. I hope these videos help you guys, and I'm really hoping and praying that you are successful in this final exam, as well as in your futures. And I hope that you've enjoyed this year as much as I have. We've had a great year, and I would like to thank all of you for making this a wonderful experience. Thank you. Assalamu alaikum.